Do the most. On the count of 3, say the number out loud. 1, 2, 3.
10.
So 10. There it is. So you want to do the first one first? Number 10?
Sure.
No. I want some actual thought going into this, okay? On the count of 3. 1, 2, 3.
28.
Woo! Yeah! There we go. 28. Nice.
Everyone say 28.
Oh, wow, that was good. That was great. Okay. So here's 28. Here's 28. Given that angle K is congruent to angle D and angle J is congruent to angle C, so if they told you angle J and C are congruent, what could you mark on this? You could say angle J and angle C. Find the value of S. So you have J and C, right?
So
what is angle C? So what's angle J?
35 degrees.
35 degrees, exactly, right. Okay, so if this is 90 and that's 35, what's angle B?
55.
Angle B is going to be 180 minus what? 90 minus. Why did I subtract those two? What do you know about all triangles? Hammer.
When you add all the values of the angles together, it's equal.
Only one word to add the internal angles. Absolutely. Absolutely. So B is what? How many degrees?
That was the one.
How many degrees is it? 55 degrees. So angle B is 55 degrees. So what equation can you set up now? 55 is equal to what?
3s minus 20.
3s minus 20, exactly. So you know that 75 is equal to 3s, so s is equal to?
25.
25. We good? We like that one? Is that good?
Yeah.
Okay, I'll give you more lead time this time. Each of the small isosceles triangles has 2 acute angles. Find angle DBC and the measure. That means the measure. Am I missing a diagram? Am I missing a diagram here? Yeah, I'm missing this, right? Do I need that? Yeah, I need this right here. Hold on a sec. Yes, Dixon.
I was going to, before you said you were missing something, I was going to explain how to do it.
Got it. Okay, so on this one, what do they mean by the small isosceles triangles? How many are there? How many small isosceles triangles are there?
On the whole thing, there's 2, 3, 4, 5, 6.
Small isosceles triangles. What are they referring to? I don't think it's 3. They're responding to the 3. I think there's the 3 of them, right?
Yep.
So angle DBC, let me just angle that, label that DBC, so that's this angle right here. And then DCB, DCB, like this. Find those angles. How do you find that? Go ahead.
You know that angle CDB is equal to 120 degrees?
Hold on. CDB. How do you know it's equal to 120? Why do you know that this is 120 degrees?
Let's see where it says it. Oh, question 31. From question 31, you know that the...
Well, you know that this is congruent to this is congruent to this.
Right.
Right. So, therefore, by side, 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 you know that all 3 triangles are congruent.
Congruent, yes.
So, you know all 3 of these angles are the same.
120 degrees, yes.
A circle is how many degrees?
360.
So, 1/3 of that is 120. Yep. So, this is equal to... The measure of that is equal to 120 degrees. Sure. So, now what?
And now you know that they're isosceles triangles, so 2 of the acute angles
2 of measure, for example,
are the same.
DBC is what equals what?
Now each one equals 30.
Well, no, but 2 times it. So if one of the angles is 120, the sum of the other 2 angles has to be 60. So you know 2 times it is going to be 60.
Right.
So you know the measure of angle DBC is going to be
30.
30 degrees. Yeah, absolutely. And what we really want to work on is communicating that accurately. So you would need to. You explained to 31 why you got 120.
Yep.
You have a triangle now, an isosceles triangle. You know this, and 120. So therefore, this angle has to be the same as this angle, right?
Right.
But you know that 120 plus x plus y has to be
180.
180, right? But you know that x has to equal y because it's an isosceles triangle. The base angles are congruent. So when you substitute, you get 120 plus x is equal to 180. So 2x is equal to 60. So x is equal to 30. Just make sure you fully explain it. Yes?
I was just confused, like it just says...
You see now? DBC.
Yeah.
So the middle, it's B, but it's not...
Yeah, okay.
If I just said angle B, is that enough information? If I said angle B, how many angles could I be referring to?
2.
3. I could be referring to the yellow one. I could also be referring to the blue one, right? I could also be referring to the green one, right? So you need to, if you remember, we're communicating this over the phone. If you just said angle B, is that enough? No, you need 3 letters. Need 3 letters. Here's why. You see this side that's congruent right here? You see that one? This side does not correlate here. Look.
Oh,
right?
Okay. Yep.
This one, it's VX. This one is NL. It's not between those two angles, right? Look, it's not between. So could it be congruent? Sure.
No.
It could.
There's not enough information.
There's not enough information to guarantee it is congruent. Not 100% guaranteed congruent. Not enough info. I have a question for you. Let's say, I just have one quick, before we move on, I have one question for you. So let's say I did this instead. Let's say I had, again, let's say I had these same triangles right here. Let's say I still had these triangles right here. Let's say I added one piece of information in. I'm going to tell you that this side right here, actually I'm actually going to add this in right here.
Yes.
Is that possible? Are those triangles congruent?
Yeah.
Absolutely. Why? Yeah.
Because they...
You can only say 3 letters.
I only say 3 letters.
Yep. We talked about triangle congruency yesterday. What? What's this? Angle. What's this? What's this?
Angle,
So-
side, angle.
Is that one of the ones? Yeah. ASA is one of them. That is correct. By angle, side angle, they are congruent. That's all you need to say right there. But if we take this away, is it guaranteed? Nope. All we have right here is angle, angle. That's all we have. Yes.
Because the
Yes.
line